Hello, good evening. Welcome back for a new live coding session on tract and its activation functions. Just let's a few words to get people situated. So this is a tract repository, and something else I want to show you is there is this repo on GitHub. The link is the one which is on top of your screen to the right. And in this repository, I'm mostly using the README to tell what I'm doing on this and to give a few links to some resources. So this is a very long series of sessions. We are in the 11th or 12th session, and the point was to compute, and still is, to compute activation functions. And activation functions in neural networks are functions that you compute after basically each layer where you apply train weights to the signal. And once you've done that, you apply the activation function. And as the weight application is essentially a linear or affine process, the activation function is a thing that gives non-linearities to your network. So it's a crucial piece of it. And it's usually not a trained part of it. It's something that the model network designer will choose and put in the right place. And these functions are simple math functions in that usually, most of the time, they can be applied to each element in the signal independently. So it's just your basic y equals f of x function. So we have an issue here with some of the notes that we took in the first session and on subsequent sessions, actually. And we went quite a long way in that we actually have an interpreter for which we can write some kind of macro code, and we have an assembly coded in ARM8 assembly that can run our macro code and compute all of these functions and a couple more. And we have had that for a couple of sessions already, because support for block 1 was working part 8. And we also did some block 2 activation. I splitted them into blocks. The block 1 are a very simple one that just typically do 1 or 2 array-specific functions. The block 2 are more involved with sigmoid, for instance, is part of block 2. And the sigmoid is an interesting case. Why? Because that's what basically kept us busy the last 2 times. So sigmoid, the way to compute it, you could compute it from its definition. So that's what it looks like, and here is the definition. So you could compute it by going through the exponentiation function, then doing the addition and the division, but the exponentiation function is super expensive and the division is very expensive too. So there are other ways where you actually compute them as a ratio of 2 polynomials. So I think in the case of sigmoid, I'm using a polynomial of degree 11 or 13, but it's all in x2, so it's not that many multiplications. So let's say 11 on top and 5 or 6 on the bottom of the division. And so I'm computing these 2 polynomials and then dividing them, and I get a relatively good approximation of the sigmoid, because on the single precision floating point value, it gives exactly the same result as this. I didn't come with this way to do it. You can use Mathematica or the tools to find these approximation for essentially every let's say every function that is computed to compute, complicated to compute. You can find a good approximation with a bit of trial and error. Anyway, so we have these. So I can actually show you the formula for the sigmoid. Formula we are using. I think I have it somewhere. At least I have it in code form. Sigmoid. Here you go. So yes, so that's. I don't have it for the single precision for the single precision. So that's 32-bit floating point value. So I don't have it for them. I have it for half precision, and it's essentially the same spirit. So you get a numerator. It's just a bit bigger for F32 because you have extra precision. So you need extra terms, and you're dividing it by another poly. Which is of higher degree in the single precision case. So that's a single precision case. You can see that we have 13 coefficient on the top, except all the even ones are 0. So we actually do not make 13 multiplication, but half of them. And same for the bottom poly. We have just 4 actual terms. Anyway, so that's the sigmoid. And what happened over the 2 last sessions is I wasn't happy with the sigmoid performance. And the reason is I have a comparison point for sigmoid because I actually did a couple of years ago a purely assembly implementation of the sigmoid. And that gives me a good comparison point. So that's my assembly sigmoid. So this is ARM8 assembly. The same exists for Intel and for ARM7, but that's the ARM8 version. So it's essentially compute the 2 polys and then divide them. So this is a division, for instance, and before that we're doing the 2 polys, and you can see that we are doing 4 call to the fdiv operation. So we are working on 4 registers at a time, and each register in ARM8, each of these registers contains 4 values. So one iteration of this loop, of this function, computes 16 values. And it's all hard-coded, so this can only do sigmoid. I have another function for hyperbolic tangent where you can use the same trick with a poly ratio of 2 polys. But so this function is the one for sigmoid, and the tangent hyperbolic tangent is a bit different because it's not the same number of terms on the top and the bottom of the division. So this is the implementation that I know will be tough to beat because it's fully dedicated to a sigmoid and it's just done to be fast on sigmoid. Nevertheless, I was really unhappy with the performance of the interpreter. So in the case of the interpreter, how is the sigmoid computed? Where I am in the wrong place, totally the wrong place. So first I need to be in the branch where I actually did something. So that would be activation, I guess. Yes, activation VM. So for this to work, first we need to define a macro language, a language in which we will describe each of these activation functions. And so that's our little language. So it looks like an assembly in that we can move on run a register to another. We can load a constant into all the lanes of a given register, and we have some unary function. So like y equals f of x, so apps and receipt. These one are binary function. They comparing register A and B and putting the result in A. These one are semi-binary, so they take a constant and they, for instance, adding the constant to the A register and putting the result in A. So it's like a plus equal in C or C++ or Rust actually. We have this one which is fuse, multiply, and add, which does roughly this. I mean exactly this, and that's the one we use the most for computing sigmoid and hyperbolic tangent, because that's I mean we're computing the polys with this function. Or at least we were. Yes, we still are, I think. We'll see. Anyway, so that's our macro language, and then for each target that we want to support, for now we are focusing on the ARM8 platform. We also define and we also implement an interpreter for this language. This is again the wrong place, so let me check. It's in linalg, ARM64, SIMD, and I have activation, act for activation, F32, because we are working on floating point 32-bit values, and the handcrafted implementation was working on 16 values at a time, but this interpreter is working on 32 values at a time. And as this is an interpreter, it's not a code for the sigmoid, it's a code for any function that fits into our model. And the thing is, I don't remember exactly the ratio because I think I have made a mental block on it, but I was expecting this to be not performing as well as the handcrafted implementation in the case of sigmoid, but it was like one order of magnitude lower. And so something we did last week, or the week before actually, so the session before, because I skip a week. What we did last time, we tried to bench a little bit the interpreter override, and to do that we added a no-op function, which is here in the interpreter, that does nothing except we are going through the interpreting loop, and we came to the conclusion that it was far from neutral. I mean, it impacted the cost a lot. It was expensive. So what does that mean? Essentially, it means, if I'm not wrong in my assumption and hypothesis and etc., it seems to tell us that the interpreter is costing us a lot. And so what I wanted to try today was, okay, let's get rid of the interpreter. We have some macro code, and we know how to translate each of these operations into actual ARM8 assembly code. And instead of doing this with an interpreter, we'll just make a big function by concatenating all the assembly snippet together that we need to implement a function. So essentially, we are moving from an interpreter to a compiler. So this means that instead of building one single function called that ARM64 SIMD activation F3232 and forget about the suffix, instead of doing this, we will generate as many functions as we have activation functions, so that's 6 or 7, and they will take one single argument, which will be the pointer to the values to compute, and no longer the program that contains a sequence of instructions to apply to each of these values. And hopefully, the sigmoid that this function will generate might be, I don't know if it will be as fast as our uncrafted operator, but at least I hope it will be better. So I'm just rebooting my testing machine, my Raspberry Pi, for later. But so let's give it a try. So if we look at this, for instance, our assembly, so our interpreter, so the actual body of the function starts there. We're checking that we actually have something to do. So if the values table is empty, we are jumping to the OK label, which is basically return 0, because 0 means everything was fine. And then we are moving to these two loops. So we have an outer loop and we have an inner loop. So the outer loop is the one that will iterate over sub-slices of the slice of value we are given. So we are given like 1,000 value, and we are processing them by chunk of 32 values. It has to be, I mean, the number of values that we are given has to be a multiple, and the code, which is in Rust, on top of that will make it so. So our outer loop will load stuff. That's the load operator here. And you can see that previously we were loading, I mean, the Sigmoid implementation is working on 4 registers at a time. Here we are working on 8 registers at a time. We are doing 2 loads, and each of these load fills 4 registers. And in each of these registers there are 4 values. So that's 4 times 8, 32 values, hence the 32 name. And once at the end of the outer loop, which is here, that's a dawn, this is the end of the outer loop, so it's symmetrical. I mean, we are storing these 32 values back to where they were coming from. And we are moving to the next values. Yeah, no, that's fine. And we are jumping ahead of by 32 values. And this, I mean, x2 is the number of value remaining, so we are subtracting 32. The address computation is already done as part of this stored operation. So here the load is loading from x1 and also adding 64 to x1. So the second load also read from the x1 address, but has been already added 34 values, 34 to the address. Here we are subtracting 128, so x1 is back where it was here, so that the store over there will also store 64 bytes and then 64 more bytes, so that's 128 values. So at the end of the dawn, our x1, which is the address where we should work values from, has moved forward by 128, which is what we want. And x2, which counts the remaining values, has been subtracted 32, and so we are ready to tackle the next slice of 32 values. So 32 values make 128 bytes because each floating point value takes 4 bytes. And then we have this inner loop, which actually is a virtual machine. So what does it mean? Virtual machine is basically you're doing in software what usually is done in hardware. So it's kind of the same thing. You need to fetch an instruction, decode the instruction, apply or execute the instruction. And so basically here, this load is the fetch part where we are loading the next operation from memory. And this is our decoding. So we are looking at the 16-bit to the right. Yes, to the right of the instruction. And that gives us a value in W7. Yes. And this value in W7 we are reading into this table that you cannot see because it's actually generated by this bit of magical. I mean, this is liquid. It's a web template preprocessor that I'm using to generate assembly because why not? And so essentially what this trick does, or rather that one, is we are looking at the address of the jump table label, which is here. We are adding to jump table. Okay, so we are putting it in x4, and then we are adding to x4 x7 shifted to the left by 2. So we're taking the value from this bit from this short here, shifting it by 2 to the left and adding it to x4, and then we are jumping to the value in x4, meaning that we are going to jump to I mean, if W7 is like 3, we are jumping to the third value of I mean, to third B here, which is in turn another jump that will jump us to the right instruction. It works because this jump table act has been initialized in a way that contains for each of the macro operation code the name of the label that we want to reach. So for instance, if we read load C, that's not necessarily a very good example, but if we're looking at an apps operation in the macro code, then it will be like I could try to find out actually. Let me show it to you because it's just a bit of meaningful comments in the code, which is grabbed. Wrong place again. Linalg src generic activation. So where are the function? No, that's not the right one. That's something else. So that's in frame activations. No, frame activation.rs. That's the one I want. Okay, so for instance here, move is 0, load is 1, apps is 3, 4, 5, 6. So apps is 3, and so by grabbing, so it's not in this one, but in this one. So essentially, these commands are searched in the code for this file and parsed to give us the list of labels that we need to jump to for each of these functions. So that's 0, 1, 2, 3. Apps is number 3, and I mean, in initial version it was done by hand, but now it's just this mechanism of grabbing the elements and putting it all together, so we can't get it wrong if we change, for any reason, if we change the macro code operator list, it will just update the jump table. We don't have to maintain it by hand. But anyway, we want to kill it. So we want to replace this inner loop. We want to replace it by just a concatenation of every actual useful snippet of code, like the one, for instance, the one in move B to A, sorry, move A to B, so that these 8 instruction. Apps is this chunk of 8 instructions, and so that's what we want to do. Instead of having an interpreter, we want at compilation time to concatenate all of these snippets to make the function complete, and hopefully it will be faster than what we had before, and if not, well, it happens. So how am I going to do that? I think the first thing I want to do is I don't want to break the interpreter, because maybe I will well, I could still find it in GitHub, but maybe what I have in mind is there is a world in which I have some activation functions which are pre-compiled, and some new activation functions that can pop, and for which I will be happy to have the interpreter. So I would like not to break the interpreter. But I don't want to repeat all of these bits of code. So what I'm going to do is I'm going to put all of them in their in some variable or stuff, and regenerate these files. I mean, complete these files by using these snippets. So let's try to see if we can do that. And so I will have the interpreter, and plus, I mean, besides the interpreter, I will also use them to generate all of the actual activation function, the 6 or 7 of them, code directly in a compiled fashion, and hopefully it will be faster. Okay, so let's move there because we are going to code. Finally, it's been what? 25 minutes of prologue today. Okay, I'm 64 Cindy, and we are tackling the activation. Okay, so the first thing I want to find out is that's something else. The first thing I want to find out is can I? So we will start by focusing on the easy ones. So that's these ones are the easy ones. So yeah, the question is how can I make a variable in this liquid template system? And I think, if I remember correctly, it was something like that. Let's check it out. Liquid preprocessor. Yes, that's what I want. Okay. So they have changed the website. So I think I need a variable, even if it will be a constant one. But I need to be able to capture some content into the variable. I've done that already, so let me try to find out if I can figure out how it was done. Is it env? I don't remember if it was env or capture, maybe. Capture looks good. Okay. Capture, assign or capture tags. Let's see. Capture. You have to convert to a variable first using either assign or capture. Okay, we're getting close, except that's not what I'm looking for. Okay. Let's look at this then. If we have examples. Okay, so it's capture, then a name, and capture. So if I'm doing capture receipt, so this is the part I want to use. Okay, and then to use it, I think when I want to call it, I just do this. Maybe with double, actually. Let's see here. So it's called packed loop 1. So this is actually the code for matrix multiplication. Okay, and to call them, yeah, it's double curly brace. Okay, so this should not break anything. Let's see if my Raspberry Pi is back online since before. Suspense. It's a bit slow to answer SSH, and I'm not sure why. Okay, it's back. I was off screen, but so if I do cargo thingy minus D, and it's gonna be 3BU64, yes. So that's just a part of the machine name in the LAN, and I'm going to do test, and I'm going to test receipt, and let's see. So this should be equivalent to what was before, because we're capturing these 8 + 1 lines into a receipt and then writing it again. And if it works, then we will have to do that over and over again for each operator and move all that stuff somewhere. Maybe just up in the file. So that's the first part. With this, we can, from there, we will be able to use the same snippet to implement both the it's super slow to go to the Raspberry Pi, even if it's on the LAN. It's a bit disappointing. But it's actually pretty warm in Paris, and this specific Raspberry Pi has a stupidly, I mean, it's a metal box, so I suspect it's overheating. You know what? I'm going to just go and because it's in the other room, and remove the box from the Raspberry Pi. So just stay there. So I'm back. It was warm without being crazy warm. So I'm not sure. Something I could try is instead of I mean, my setup here is very crappy, very mercurial. I should try to wire everything because I'm in the middle of Paris, and so the people density is crazy high, and everybody has Wi-Fi, and everybody thinks that the Wi-Fi sucks because I mean there are too many of them and it's completely saturated. So it's a bit of you know who is going to have the biggest Wi-Fi router around, and only this person has decent Wi-Fi, and everybody else is suffering around. And so it's a bit of an arm race to who has the biggest, the most powerful Wi-Fi thingy. So I should try and have everything wired, but it's a bit of a mess in this place because I mean I need wires that go across all rooms basically, so it's not super easy to do. So we need to endure a bit. So for now it's compiling, and now I'm asking it for a release compile. So that's also slow for different reasons, but release compilation gives us a smaller binary, so they should be faster to transfer to the Raspberry Pi and run. And something else I could actually try in the meantime is I can try cargo test, and instead of using an actual device I could use a QEMU emulator, because for tests, I mean as much as I want benches to run on actual devices, the test can run on anything. I mean anything that works. So that's, and I'm going to test to check that the emulator is actually running. Oh, the other guy is waking up finally. Okay, so recipe seems to be working, and to make sure, we're going to do something a bit obvious. Recipe, I just want to make sure that I'm actually testing what I'm running. that I'm modifying. And okay, that's good. So we're back in business. So now within recipe, we need to do all of them. So up. So we have a bunch of them which are easy. It's just gonna be an absolutely fascinating process for you. And not at all boring for me either. So we are all in this together. So that's apps. Then we have add. So what can I do to make it not painless but less painful? I'm not sure I can do much in terms of yeah, editing, crazy, foo, whatever. What I can do with this, maybe. Yes, that I can do. Let's at least do the easy ones like this. Okay, min, max, FMA, and a few more, so soit BNC. Okay, and that's it. The one are not implemented yet, so we will leave them alone for now. So we did capture something. Now we need these two ones, and I'm gonna do the same. And then we will need to fix the names. Up. Mul, min, max. Min, max. FMA. Forgot that one before. We'll fix it later. So let's fix it now. So that's capture. It's not add, but we'll call it capture anyway. Okay, back. So the move ones are a bit of a mess because we have several of them. We'll see what we can do later. Let's finish that part. So apps, fine. Recipe, add, and capture. No, nothing to do here. Add is fine. Sub. Okay. And capture. Sub. Mul. So capture mul. And maybe I can save a few keystrokes like this. Raté. Again, yes. Min. We could go beyond because we have a test preprocessor, and if you make min here a variable, then min, we can change all of these by doing f plus a variable, but okay, come on. If I'm doing this, we're not doing assembly anymore, we're doing weird stuff. It's already pretty weird, so let's try to keep it sensible. It's not that painful. Okay, so now we have add const. So the compilation is just doing nothing to help me. It's dramatic. Add const. Forgot that one, so it's okay. So that's sub const, and I'm using sub const. Mul const and mul const. Min const and min const. Same with max. And max const. FMA and FMA. If pose then else, so if pose then else done, if pose then else, if post, nice one, if pose, if post, yes, that's where VI found it. I mean, I'm the one who put it there in the first place, but so FMA is done, if pose and else is done, then swap B and C. Swap B and C. Swap is different story, B and C. Swap B and C. And that's all for the easy one. So we're gonna do one run of QEMU test. See if we have missed something. I don't need the res flag here, because here we are in local, so we can just do the stupid compilation, and I will not limit it to receipt. I want all activation function tests to run and see if we have broken anything. Looks lots of green. Okay, that's good. Then we have the question of what we do is move and load, because in the case of move and load we have actually a second jump table. So this one is written by hand, and I mean, I think the move are rare enough in our example so that we will just except I can't do that, because if I have more than one move, no, we need to find a way to do that properly. So what are our options? We could actually change the encoding of yeah, we will do that, because it will make a lot of things easier, I think. So let me try to explain what I have in mind. It's in frame activations. Nope, not this one, but that one. Yes, please. Oh yes, we looked at the code. Okay, so we essentially have encoding move as one operation with two parameters. Each of them is a register, and so a register can be A, B, or C. We have three registers in our virtual machine, and so there are six meaningful or six useful move operations because the no op ones are not interesting. So these are the one move A to move A from B, move A from C, B from A, B from C, C from A, C from B, and the other ones are either some artifacts of the fact that I looked at the values in terms of multiple. I'm doing first register multiplied by 4 plus second register, and so that gives me 16 combination, but all the combinations that are using a fourth register D that doesn't exist are unsupported. But that's just it's just the way I did this jump table. So what I'm proposing here is, instead of doing that, I'm going to do move A from B, or move AB. We'll consider it's good enough. Move AC, move BA, move let's do B from C, move C from A, and move C from B. And so we need to fix these. So let's forget about the assembly for now. So now instead of because we have two, I'm not sure if you remember that, but we have two series of instructions. We have the high level ones, and we need a translation step that was covered in previous session. So let's so this is the lower list of instruction. It's subtly different, but not that different. We have the down operation and the constant are encoded differently. Anyway, so move AB. I will go actually there and up, cut and paste all of these, and we will do the same for the loads after that. But the load, there are just 3 of them instead of 6, so it's gonna be easier. Where is it? Yes, it's here. So that's gonna be jump to. Come on. Jump to move AB. I should probably try to speed this up a bit. Yank, past, 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 so I can get rid of this one. And so that's AB, AC, BA, BC. It's a lot of repetition. CA and CB. So that's for the loads. Then, so that's translation step. So it's going to be very stupid. The ops move. Let's take them in order. AB will be translated in char op. So char stands for kernel because it's lower level. So kernel means kind of low level in this context. Okay, 2, 3, 4, 5, 6 of them. This one goes away. Plus, oh yes, plus. We need this around. Up, here we go. Here we go. Again. There was a faster way. Again. And again. and then we need to just close the braces and the parentheses. Here we go. Yes, that one goes away. So we've done the moves. Or maybe not. Oh, we need to fix the constants. So move AB. Oh, yes, or AB. So again, AB, AC, BA, BC, and CA and CB. And same here, AB, AC, BA, BC, CA, and CB. All right. Super fascinating code today. Knowing that we also need to do that for load. But why is it complaining here? Yes, I know why. So we have also to fix the Rust generic implementation for the activations. So it was done like this. Move again. Okay. Thinking how we can do this one. Why did I do a split? Yes, because I'm looking into this, the split this guy in two, and depending on which one is left, so maybe we can do something much easier, like care up, move A to B. We will do something like so left is A dot copy from slice B. Will that do it? Something like that. I think that's what we want. And it will be so much easier than what we had before, actually. Except we need to repeat it 6 times, and once again move AC, move BA, move BC, move CA, and move CB. And so we're moving A, we're moving to B, we're moving to B, we're moving to C, we're moving to C, and we're moving from B, we're moving from C, we're moving from A, we're moving from C, we're moving from A, and we're moving from B, which is correct. Okay, so that's the moves. So at this point, I think the... So I will not try the QEMU one, because this one will try assembly stuff that we haven't fixed already, but we can try the we can try this, because okay, nope, it doesn't even compile, so we need to fix the tests. So other test, SRC frame, activations, test. So we have move somewhere. Okay, so instead of, yeah, these are simple to fix. So instead of doing this, I'm just going to do that. And I think one of the side benefits is I will no longer need this register enumeration, because load will be moving away from it too. So we have more of them. Okay, so that's move B to A, so it's still a move AB. There we go. Another one. Okay, that's good. So where are we now? Oh yes, of course. So we also need to fix our function definition. So there are not that many move, but still. So okay, one more. One more. So this is a sigmoid. So there are a lot of, there are a couple, more than a lot of moves, operation, which we need to fit into our framework. Ok, liquid, merci. And now I don't know, I don't remember what I was saying. Yeah, on this sigmoid implementation with our macro language, we still have more than a couple of moves that will slow everything down compared to the uncrafted implementation that has just none of these extra operations. But still, the difference of efficiency between the two was so big that I guess we can do much better. Even if it's probably not be at the level of the uncrafted implementation at the end. Okay, so we've done move. I'm gonna test that the generic bits are working. Okay, so now I'm going to fix our implementation in assembly. For the move, so before the move was all of this, decoding sub bits of the instruction, then going through jump table. So now I just need to basically do that. That was, whoa, it was a good fix. So we have discarded a lot of assembly, so probably a lot of bugs. And that one I'm going to test with QEMU. Yes, I did that before actually. I don't plan to do a JIT. What I had before was an interpreter, and I want to move from an interpreter to a compiler. Because basically the quick measurement that we did in the previous session show that we are spending a lot of time in interpreter code in deciding what to do next instead of doing stuff. So I'm preparing ground to be able to, instead of so this is, for instance, the implementation of move C from A. And instead of having a jump table over there and some bit of an interpreter here that does a loop over the instruction, I want to concatenate these chunks of useful stuff and make a big list of instruction that hopefully, as it will be free of any decoding and operation fetching overhead, should be faster than the interpreter. So that's where I am today, and I'm not sure. We're already 1 hour into the stream. I'm not sure I'm gonna be done today because there is still a lot of ground to cover. What was going on before was after doing, we were simplifying the instructions. So we did already the move, and the other one is the load. So the move was 6 sub instructions, and the move is just 3 of them. Thank you. And that's so yeah, here right before there were one move that were taking 2 register as parameters, and we are going to do the same with the load. So I'm going to get rid of the register and putting load A, load B, and load C instead. So I can get rid, I think I can get rid of this guy now. Bye bye. And I just need to fix everything now. So load A, so that's translation. So translation from high level to low level. So now we have load A, B, and C. B and C, which are going to jump to load A. So these are called jump to, but actually it was jump to because this was generating the jump table. But now what I will use this for is I will use these labels and stuff to not do the jump table, but find the right snippet of action that I need to concatenate in the big function that we are going to compile actually. So the moves are done, the loads are done. We need to fix this. So this is translation from A to B, from high level to low level, and so now we will have 3 translation. So load A. So A was load A. Yes, A was the register. So now I just have the constant to deal with. And so the constant actually initially they were in a separate stream of constants, but at some point we move them inside the instruction stream. So in the case of instruction that takes a constant, the important thing is op or constant. Every bit in the instruction stream is either an operation or a constant, and depending on the operation, there is or there is no constant following the instruction, and the instruction is responsible for fetching the constant and updating the PC or instruction pointer, next instruction pointer when it needs to be updated. Sorry, that's just something stupid. Yes. And so load A, load B, load C. I need to adjust this, and that's fine. Okay. Next step. The compiler will remind me what's missing anyway. But so we can go and have a look at the tests in activation tests. 2 for 1. So we have a load. So this becomes load B 1.0. Let's look for the next load. So that's load A. Okay. With the constant following. This is load B with a constant. This is load C, also with a constant. I'm pretty happy that we have all of these tests because, even if it's tedious to update, it makes everything so much safer. Load B. There are more. Load B with V. Prop tests, yeah. Oh yes, lots of prop tests. And I will not do the song. Prop test BV. And actually, yeah, these are actual prop tests. Yes. 30, you think? Yes, so I will do it like that. B load, and replace this with load B. Okay. Nope. Come on. Yeah, I guess there was something to escape. Do you think there are so many of them? Do you really want me to humiliate myself by failing to do a search and replace? That's not nice. Let's try again. Load 39. Okay. Okay. Trying again. B. Yes, that feels better. Load B. And yes, that should be okay. So that's for load B's, but I guess we'll also have load C's, like this one. Load C. Here we go. 13, yeah, 13 left. And now, bloop. Okay, so register ID is gone. Because now I've made it a part of the operation code. So I don't need arbitrary implementation anymore. That was a bit of prop test. More register ID, 44, yes. Register ID, no more. Okay, so we still have a load unqualified, that's in definition, so we need to fix the definition. So we don't have any load, nope, not looking for, I need to look for register, okay, that's done here. So we are moving to the definition, so that's where the various activation function that we want to support are implemented. So register ID goes, and we need to look for loads. And should I do the search and replace again? Load C becomes, yeah, that looks good. And what else? So we're moving to generic activations and frame activations. Conflicting representation ints. I want to look at this one right away. So yeah, so before we had an enumeration with enumeration. Sorry, with values. Heavy enumeration in Rust and not in C. So what happens is now we don't know anymore. So we need a double. We need to specify where we wanted to code the enumeration discriminant, and how to encode the actual discriminant content. Okay, so that's warning because there are still a couple of loads remaining. I just want to check that size of. So yes, the opor const is meant to be is meant to be for long, so that's a U32, that's correct. Anyway, let's move on to the next error. In generic, generic is the Rust implementation of the virtual machine, and the purpose of this is to deal with a platform for which we haven't coded the assembly. And so what should we do here? Let's try care up load A, and we will need to read the constant, which is the next item in the instruction flow. So that's what this does. And once we have this, we will do that. And I think there is a faster way to do that, but I mean, if we are in the Rust fallback, we're already in a bad shape, so I don't want to worry too much about getting the faster implementation here. Just want it to be correct. Okay. And this one goes away. I think I should have registers. Yeah. Register ID up. Bye bye. Okay. Where are we now? Generic activation. Yes. Okay. Just because it's double mut, I mean, A doesn't need to be mut because it's already a mut reference. Segfault, that's okay, I guess, because we haven't done everything. We haven't done the a.fill. Yeah, a.fill should probably work. We're going to give it a try. We haven't done the armate assembly fix yet. So you're suggesting a.fill alias memset. Yeah, it sounds good. And it's nicer. I could actually even try to collapse a.fill. Yes, I can do that. Okay, so let's try to run again the tests on Intel, where I don't have any assembly, so the only code which is tested is this very Rust fallback implementation. A bit of a warning here in frame activation tests. We're not going to worry about this for now, and or we will. Line 4. I don't need the prelude anymore. Bit suspect. Okay, let's see. So now we need to fix. Oops, not what I wanted. Sorry. Sorry. Tmux shortcut. Maybe the prelude was only good for the arbitrary implementation. You're probably right. It's good to have experts around to help. And then we need to fix the ARM64 code. So it's going to be easy because similarly to what we did a couple of minutes before for the move, we are essentially going to remove some code because instead of going there on a second jump table, in the main jump table we jump write to the good instruction directly. Okay, so that was, yeah, sure, that was the Intel test. So let's do the QEMU run, test that the ARM code is writing to. Segfault, cool. Where is it? On the max const 0 failed to initiate panic. Okay, super nice. Error. Okay. A bit unexpected. Is there anything obvious that I did wrong? Let's have a look where it could come from. Load A, load B, load C, that's fine. We still have the jump to the inner loop in the three of them, okay. That doesn't look like anything has been broken here. We have move AB, it ends with an inner loop, AC inner loop, BA inner loop. All of them end with the inner loop call. So I'm going to try again, and this time I'm going to do a no capture and test threads once, because here I don't even know which test failed actually. What? QEMU, cargo dinghies, that's the test code there, and double dash goes here. So we are failing on add prop. Index of the bound line is something huge. The index is 2. Out of bound, really. Add prop. What did I do wrong? And we are, yeah, it's the assembly code which is failing. So let's try. I'm going to try to run the generic code before, just to make sure that this one hasn't been broken. It does a bit more. I mean, it also did the matrix multiplication code, but that's fine. Okay. Let's do this again. Not this one, the one that was working. So that's this one. No. Nope, that one. That's generic. Yeah, this one has always been working. I just want all activation. Okay, still broken. So there are two ways to do that. The hard way. I think my connection reset again. La connexion, yeah, la segfault sur ARM at full stream. Yes. Yeah, as I was saying at the beginning, I'm sorry for that. The box is, my box is, I don't know why it crashes on a regular basis, and it's super annoying. I just need to have it switched, but I just need to do it. Anyway, let's go back to business. I haven't done anything except running a couple of tests more, so you haven't missed anything if you come back. Anyway, so one way to do this is try to guess what was wrong. I mean, I'd like the stream to be back, and the stream should be back, but it's not moving at all on my tiny monitor. Okay, no, yes, it's back. Yeah, the segfault was in the box. It doesn't need a segfault to crash the box. I mean, it has a tendency to crash at the worst of time. It actually crashed during the rugby match on the other day. It was super annoying. Okay, so I can use Valgrind, I can use GDB, I can try to guess what I did wrong. I'd like to guess a bit first. So it looks like it fails on the add prop test. So let's have a look at this test. Not here, the test is not here, the test is in frame. SRC frame activation test. And the add prop test here, we change, well, I mean, we just, we did change this load by a load. Does it make sense? Yes, it does make sense, because this reads, we want B to contain V, and we will add A to B and store them in A. A to B, I mean, A is A plus B. And what we are testing is that x becomes x plus v, so it's consistent. So I'm pretty sure that it was actually a load register B. So could it be a problem? Let's have a look at the translation. I mean, the translation is in Rust, and it seems like it's working, because when we translate to Rust, I mean, when you translate from the mid-layer ops to the lower layer ops, and then execute them with the Rust fallback, it works. So I'm going to assume that the translation is not where the problem is. So that leaves us with one specific place, which is this. So I was thinking that maybe the mistake could be there, but it doesn't look like it, because we are actually doing loads, and because, I mean, in that case, if we get the opcode wrong for most of the operator, we will just, could it be the rup change? It could be the rup change, to be honest. It could be the rup change. It could be the rup change. But I'm actually testing that the operation size is the right side. So, oh, it was, okay, let's have a look at this. That's a very good call, actually. So we have the union here, which is rup C. And so it has to be, this is why I want a care hop to be 32-bit, because either I have an operation, an opcode here, or I have a F32 value in T. So I'm probably testing with the size of, not there, but here I'm testing that op or const F32 is 4 bytes, and I probably want to test also that care hop. Just to make sure. So I want this guy to be F32. And I think I have now an idea of what is wrong, because yes, I know. So it is actually the representation change, because my assembly my ARM64 assembly. Thanks for this. My ARM64 assembly here assume that the opcode is in the last 2 bytes, so over 16 bits in the opcode. And now I don't need this anymore. I can just read. I can just fetch a 32-bit value in W7 and use this to offset myself into the jump table. I think that could be it. Except, to be honest, I think it should still work even with the end. Because the value is the same. So no luck here. Okay, we're going to debug. So if you want to debug, it would be nice to have a test which is not prop test based, because we don't know if it's the first thing it tried that crashes. So to do that, what I'm going to do is I'm going to do a prop test fork run. And what's the point of this? When prop test fails, it is supposed to give me the example that failed. But when the fail manifests itself as a crash, prop test being in process is not there anymore because the process has crashed. So by doing prop test fork, I'm making it making it significantly slower. But if this means that actually before each of the individual tests, we're running them in a separate process. So prop test actually in the main process has a chance to intercept the failure, even if it's a seg fault, because it's the second process that has seg faulted, and can give me an example of something that crashes. And so I have a problem with move B to A. Okay, that's interesting. So let's check it out. Move B, or actually move B to A, so that's move AB. This would be this guy. I mean, it's hard to see what could be so wrong there. Unless we have a problem of generation of code, that would be super weird. I'm still going to try that. I'm going to do cargo clean, because if for some reason the code is not generating correctly, I mean, if we're not maintaining the synchronization between the jump table that is extracting from the jump to labels in the code with the assembly, then I mean, the jump table just do whatever it wants. So that way, I'm trying to make sure that it's not something stupid like that. And because honestly, I can see if this can seg fault. I mean, it does, so there is something wrong. Oh, I know. This time I know for sure. Yes, I know. So it's not the move the problem. The problem is the load, which makes sense because first we did the load, we did the move, and everything was fine, and then we did the load, and everything was not fine anymore. And that's because here, for the load, I have a constant. So we need to read the load A, load B, or load C opcode, and following this, we must read in the instruction stream the actual constant to load. And that's what this code was doing before doing the small jump table for the load. And we are not doing it anymore. So basically, we are reading the load instruction, and then we're interpreting the constant that follows as an instruction, which obviously cannot work because the f32 value has very little chance of being a small integer that can fit in the jump table. So we actually need to cut show this moves forward the instruction pointer of one step. This loads from W3, which is okay. Let's have a look at the assembly. See, M64, not there. M64, SIMD, M64 SIMD activations. So load. Okay. Yeah. So in the main loop, yes, this is there. This is it. So here I'm always loading two 32-bit values. The first being the opcode, and the second being the constant for the opcode, or the next opcode, in which case I will not use it in this loop, but in the next. And I'm moving forward by 4. So meaning that if I do this twice, then the one which is in W3 in the first load will, the next value will be in W7 in the next run. So let's get rid of this. Read 8, but only move by 4, as the second word could be a const. Exactly. And so if it's a const, then in the case of loads, here we go. I need to load, I need to move the instruction pointer by one slot, say. I need to put in V24S, I need to put whatever was in W3 because it's a next, it's a constant, which is in the next slot. And what's next, and the rest is decoding the register for loading. So I think we've done everything we need to do here. So I'm just going to duplicate this in load B and load C case. They are also using V24 as a placeholder for loading the next, for loading the value to fill. And so that should be it, actually. So it was not the representation, but a good idea. And yes, it's working again. Okay. So what did we do today? Actually, because it's been 1 hour and a half already. And so we essentially simplified our assembly and made at the very beginning, we actually did some web pre-processing thing where we prepared each of the useful snippet and put it in a capture thing. So I'm just going to do the same thing for the new instruction that we have created. So load C will be capture load C, load B, yeah, liquid, load B, move, okay. So these are going to be move A, B, Move AC, more fascinating code and code editing. BA, BC, CA, CB, CB. Okay, and at the end of the section, tiny typo and move BC. Thank you. And so I need, yeah, that, this, this one, move AB, move AC. So once again here I'm gonna fix the usage of each of the new defined variables, but basically I just want to make all the useful snippets reusable by another by the compiler. So okay, now we just need to fix this is going to be move AB, move AB, move AC, move BA. That's a problem with live coding. Sometimes it's just really editing stuff. BC, move. Yeah, I haven't fixed them yet, but maybe there is something more. I'm gonna double check when we get there. Thank you anyway. Move CB. So load A capture should capture load A. I guess that's what you mentioned, liquid. And load A, load B, capture load B and store, reuse load B. Load C is capturing load C and we re-outputting it. Okay, let's try this. Looks pretty good. Okay, so I think I should commit this before breaking it again. And I think the next steps are moving. I don't have to do it, and I don't have to do it on stream, so maybe I'll leave this alone. Okay, let's commit this first. Bloop, 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 bloop. Bloop, 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 bloop. Just having a quick look, but okay. So essentially, we've split loads and moves plus capture snippets. Okay, so what's next? So at this point, we have if you want to compile stuff, we need two things. We need a translation, and a part of having the translation is what we just did. So that is isolating the snippet that we are going to use as the compilation output. But we also need the program. And in the current setup, the programs that we want to compile are defined as in activations definition. They're here. And the thing is, if you want to move to an interpreter with stuff that happens at runtime to a compiler with stuff that happens at build time, well, these programs were only available at runtime, and now we need them at build time, meaning we will need to call them from something which is a call by the build.rs file and not by something which is in the src library lib, src lib bundle or whatever. So we need to move things around. Could we? I mean, what should we keep? We could do something. We could do something dirty as I did before with the jump to statements. I mean, the jump to not statements, comments. I mean, the one that we checked before. So this. These comments are actually making the link between what happens at runtime when we use this enumeration and what happens at compile time when the assembly which is generated at compile time is actually assembled. And we need something similar. I mean, we could do something similar where instead of expressing these definitions like this, I mean, we make some simple string representation of each of these functions and build the rest from there. So that would be one way. But to be honest, I'm not a big fan. I think it will be messy. Another way would be an extreme way would be to take these file and its dependency. So we have LA datum and we have program, and make them a crate. That's just a file with like 7 functions. It would probably be the cleanest way. It could also be, I mean, it shouldn't have to be super dirty because it could be just a subcrate of this one, but adding a crate to Tract is a bit expensive because then I need to release them. And I release all of them in lockstep, and the release process is a huge thing already. So I'm a bit reluctant to do this. So that leaves me with another option, which would be to tweak a bit this file. So by some usage of configuration flags, maybe I could make this file compile in the context of, this file plus a few more. Like I will need the enumerations for these things. So I could maybe include, and this is where I'm going. I'm going to do something dirty with inclusion and files. I'm just trying to figure out what I need beside what is in this file, because there is the T thing. Obviously, I don't have the tensor, which is good news. I just have this LA datum, so I could have a type def for it. So I would need the program, but I mean the program, as you can see, is just a list of ops. So maybe, and I think I'm going there, I will replace the program by a list of ops. So that's one type less to manage. And then we will just have the LA datum thing that we could manage somehow. We will find out. Okay, so let's do this. So first, I'm going to replace program by just a vector of t, just like this. So program of t becomes a vector of t. Here we go. And then program to this stuff. Trying again. Yep, that goes away. And I'm going to do another one for the ops. So now I'm discarding the ops. I'm going to keep the vec. Okay, making some progress. So I have this stuff to discard. Nope, that one was fine. Okay. Extra curly plus comma, extra curly plus comma, extra curly plus comma, extra curly. Okay, this one didn't. Ah yes, because it was a vec of t, and that's for f32. What? What? Expected f32 find enum. Yes, sure. Expect op of f32. So why are they different? It's because this one works whatever t is, whereas that one, I mean sigmoid, in the f32 case or in the f16 case, we will want to do different computation. So we have, I mean, this is really sigmoid for f32. The sigmoid for f16 would look different. So something doesn't. Okay, let's start at the beginning. Vec expected type parameter found op. Okay, yeah, I got all of them wrong. So I need to replace all my vec of t by a vector of op of t, and that should be way better. Okay. Why is it complaining? Attribute on expression. Okay. Should I still? So the reason why we had this was to avoid them going on sometimes in one line and some other in several lines. But now it become very simple. So let's just leave it alone. That's terrible computation for one fix, but it will have to do. Okay, so I got rid of the program. The reason why there was a program initially, it was because the program was both a list of instruction and a list of constant separate. But now that we've made, now we've put the constant inside the instruction, we don't need, I mean, we can not use the program anymore, but just use the vector. So I'm going to replace program of t by vector of op of t, and this time I'm trying to Okay, do the right thing. And I can see that here I'm doing something weird because I had a care program. Yes, should I keep it? We'll see. Okay, where are we? Do we compile or do we still have problems? We still have problems. Cannot differentiate. Okay. So I guess I have a trait somewhere that were implemented by program, and oh no, it's even more than that. So yeah, it was a method on program, and now program is no more. But I cannot have translate. I could do something like that. Trait vec op extension. I'm not too sure I want to go there. And he defined translate again and implement vec op ext on vec of t. But I mean, there is no point because translate is not called by code outside of where we are. I mean, outside of tract or even outside of this crate. So we'll just do it like that and make it function instead. So self becomes program, for instance, in prog. I guess I will have curly too many. Yes. Okay. I still need to be generic on T, and I can use LA datum. And what's wrong here? Yes. Okay, so translate now is something I need to call like this instead of a method. And expected, okay, that's an easy one. Here we go. Okay. Is it worth doing some test? Yes, it was worth just at least to check that the tests were still compiling. So let's have a look. Frame activations, test, and what do we have here? 320. Okay, we have yeah. So I guess all of these ops will have to go. Do we have other .ops? I don't think so. I mean, we have others, but this one do not have to go. So because we have, I mean, we replace the high-level program by yep. So this have to go. So this become vector of t. Same for this one. And here a bit of simplification. Same here. And so that one is still, so I'm doing prog to vec prog. What is prog? Prog is this, and it's a nope. So I'm calling translate again, but that's, I will need to make sure the function is public. And I guess I don't need to do more than this. So prog comes from, yeah, so translate. I will need to import it. Okay, all good. And so then we have all of these ops all over the place. but I guess they are at the end of the file where we're actually testing end-to-end activation function here. So I think that I can discard all of these .ops and be done. Just going to be extra careful here. S /ops 9 sounds good. 9 is good. Okay. So here we have found car program. Oh yes, that's the exception. In this one we need to access ops because a prog is a car program. We could maybe do the same and switch to a vector here, but we don't need it. So sounds good. Tests are running. Gonna be a lot of green. Okay. Okay. Let's check what we've done. Ah, yes, of course. Okay, this is also commit definitely. Even if, yes, is this just a reformatting thing? It looks like a reformatting thing. Did it slip somehow? Going to run a format on this file just to make sure that, yeah, it did some changes. Hopefully the diff will be cleaner. Yes, this has actually changed. That too. Okay, well, that's... What's the change here? Load B, load C. Where is it? I don't know. Probably space somewhere. We still have a lot of changes. Okay, it's not too bad, so I'm going to commit it. The thing is, we have macros in this file, and macro tends to, I mean, probe test macro, and specifically, they tend to break the formatter. So, it's, I guess it's as good as it's going to be. Fix. So we did what we did. Remove the prog type. Okay, so if we come back to what we were doing before, the entire point of this was to make it easier to reuse this very file in a different context. So we still have a problem in there. We need op. If you want this file to be kind of standalone, and op is defined just one level higher here, so I could just move it because we'll still have the LA datum problem, but that's about it. Does git diff minus W work better since it really know it's space? I will try it next time because I didn't know that. So I will try it. If, yeah, hopefully I will remember it. Okay, so so LA datum I will treat with a type def, something like that, I guess. But program, I mean op, I need in this file. So I will move op to a separate file altogether, I think, so that I can include it in activation. I could move it to definitions too, but it doesn't feel right, because definition is to define the program that we are going to use. I mean, as long as it was a VM, but now the program that we are going to compile. Even the name is not great, but it would feel wrong to to merge this. So I'm going to define one more file. Frame activation ops. And I mean, I'm reluctant to use ops also because there are so many things that are called ops in Tract. I could call them micro ops. Okay, we'll stick with ops because that's what it's called now. So activations, frame activations, activation definition. No, it's in the main one, activation.rs. Here we go. So I want this one to move on there. So I'm going to make it a new module called ops, and I'm going to use here. I'm going to go to do the easiest thing like this. Okay, so we still have the LA datum problem. That's gonna be an easy one. Yes, because I could actually define LA datum in the build.rs, and as it's included with those op kernel ops. Those ops. So I mean ops. We have. I have this one, which are high-level operation for the activation virtual machine. I have these guys, care hops, which are the one implemented by the kernel, and so it's a different list. And that's just in linalg, because in neural networks, everything is an op. So if you look to core, if you look into core, there will be ops, as you can see, and all of these are ops. So I mean, a convolution is an op, matrix multiplication is an op, everything is an op. That's really the reality of this. So, and when you're talking about assembly, then it's back again to ops and to opcode and stuff. So yeah, exactly, it's ops all the way down. So this is why I was a bit reluctant, but maybe before merging this, if it comes to that, maybe I will try to be a bit more specific, like I don't know, calling them act ops or act VM ops, or I don't know, something to avoid reusing the term again, but it's really a bit messy. Frame activations ops. Yes, just quick check. Why is it so slow? Is it expected? No, it's fine. Okay. So let's do this. Moves VM ops to their own file. So now the question is, will I manage to compile this file, and as a definition file together inside the build.rs to do something with them? So here I just have LA datum, so let's give it a try. Here, yes, I've done a lot of these tricks where I'm reusing files from different places and stuff. So here, what we want to do is we want to make a module in which we are going to load, let's call it act. And so I'm going to mod ops, and so this guy will be path equals nope, src frame activation. I could even have ops of t in build.rs and types ops t la datum included mod ops t in the main crate and type ops t la datum equals included mod ops. Ah, yes, it's true actually, to avoid the type def on la datum. Could it work? Because in definition in definition I still need 0 and 1 on. I mean, I kind of need LA datum in, to be honest, in activation already. Let's try this first. But I could hardcode something like make LA datum F32 just for today, you know, to be able to move on. And so, okay, unresolved module, can't find module file, act, src frame activation ops. Why doesn't it want to go there? Okay, so right, so if I'm doing this, couldn't read linalg act. Oh, yeah, act doesn't exist, so I do not think. Okay, I would have preferred to put them in some module, but for now, again, we'll do a lot of for now because it starts to be a bit late. And src frame activation, so I need definitions. Let's see. Okay. So, how does it start? So definition is going to use src frame activation definition. It's starting to use super ops, so I need here to use ops op. Okay, and then I have the LA datum thing, so I'm going to type LA datum equals F32, and oh, it has to be a trait LA datum. So actually, I mean, if I remember correctly, LA datum is just defined here, and I could make this a separate file, I guess, because it's just a bunch of stuff from stdlib, except that one. But I mean, it's a crate that we have already compiled when we get there, so it should be okay. We have this, but only in tests, so we're not going to be using it. I think the two ones that can be problematic are these two because they're coming from the num traits, so we would need bounded two actually there, and these are coming from bound traits. Other option, because I'm using the fact that, I mean, when I'm doing the program, I'm not using much in definition about them, activation definitions. Basically, I'm using 0. I guess I'm using 1. Yes, here to compute 1/6 and 1/2 in very, very weird fashion. So I'm just using 0 and 1. So should I do something like that? Just again, not for real, but to try and get something that work tonight. Could not find, it's not num, it's num traits. Okay, so that's a build dependency. So let's have it. What happened with the alphabetic order here? Okay, let's stop changing it. Fate to run build script on some packages. Why? Okay, we're gonna get crappy error messages. So, LA datum is not implemented for F32. Oh, yes, it is. Of course it is. This is super dirty, but again, I just want to get to some place where I have something working. I mean, I don't think I will do the compilation tonight, but at least see what we have to do for this to be able to work and not divide t by t. Yes, of course. Okay, I will need div, I will need add, of course. Now we can all see it. So that's std, oops, add, and std, oops, div. So I really want LA datum to be reusable by build the same way that the rest is reusable. Where are we now? What's missing? Expected type parameter find associated type. So I need, this is because I need to specify the output. Output equals t. Same for add. Output equals t. Equals equals what? Self. All right. Can't click private trait, so that would be LA datum. Okay. Hey, we're getting somewhere. So now, now we have definitions, and we'll try to do one. And so this build.rs is it's an absolute mess. How am I leaning this monster? 400. Okay, and it's not getting any better. So I mean, at one point, and we are really not improving it now. So at one point, it will need some big refactoring. But anyway, we decided that it was just quick and dirty to experiment. So I'm just going to add. So I want to expose the sigmoid activation sequence of operator as a list of operator, which it is, and then I will want to, if I can do that with liquid, and I'm not 100% sure, we're going to try to, well, generate the code on the other side, in the assembly side of things. So let's try this. So what if I'm doing this first? So that would be definitions. sigmoid. Okay, so it needs to be, of course, of course, it needs to be CRD serialized. Okay, can it be CRD serialized? It could be because it's basically a giant enumeration. Okay, I mean, we are going down the rabbit hole and let's chase the rabbit a bit more and see where it gets us. Activations, definitions. I don't even know if I have CRD. Yes, I should have CRD already, right? No? I don't have CRD yet. Whoa, this is starting to be a mess. So do we want to go? I mean, sure, I don't have CRD. I can add it. I can add CRD. It's already there, at least. So CRD. CRD dot workspace. The thing is, how am I going to say that? I mean, I will need a conditional. I will need a conditional. I will need a conditional derive, right? Because I want the activations. Oops. I want this to be CRD, but only when I am in the context of the build.rs and not when I'm in the context of the rest. There is another way, which is not to implement CRD, but to translate these to, let's say, strings. I mean, each of them to a string, which is just a name, plus an optional constant. That could work. And that would avoid CRD. What about it? Okay, let's forget about CRD for now. Don't want to go there yet. So instead I'm going to do to per implement how is it called already? Op of TLA datum, op of TLA datum, and I'm going to translate these into fn2 per so I want static string that will be just the name of the so we're going to it's I mean forget about typing now, it's just about getting it to work, or finding an even bigger problem on the way. Cannot find T. You should look a bit harder because there is one here. LA datum, it's just that I'm always confused by this syntax. Okay, match self. So we essentially have two case. We have the loads and the 5, 6 const operator where we will put an option of t. So if we have one of these, so I'm going to write it like this, replacing big T's. Oops, nope. I'm going to replace big T's by small t's. I'm also going to replace commas by pipes. Commas by pipes, yes. And let's get rid of all of this stuff. And in that case, I'm returning I wanted to format it to get the static string, but it won't be static anymore. No. Okay, so I will need to be strong and patient and do it like this. And let's go. And so each of these will be, I'm going to add use up like that. Okay, for now there should be a derive to do that actually, but there is always a derive. That's move AB known. Okay, it's going to be boring. I already have the comma, so yank, wrong place, past, 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 past. This one are going to be a bit different, but for now, okay. And can I do it? Can I be smarter? I can be smarter. It's just I'm starting to be tired too. So move AB. Let's try to keep the same same mnemonics. BC, CA, CB. So this one are load A, load B, load C. I need small t's. VI gets in the way. And here I will just use T. Nope, T. I'll probably have to say that it has to be copy. There are options, so it's a sum. Yes, like this, right? And same here, I want apps and apps known. I mean, nope. Recipe. Yes, yeah. I mean, I still have a relatively big PC for this, so okay. Can I? What should I do here? I'm going to do it like that. Up, add some t. This guys become small t's. Add sub mul min and max. And max. Nearly there. So here we have small t, and I'm going to cut this. It's past, and it's FMA. Okay, so these ones, let's replace comma by a row. Okay, I'm going to use this one. Swap BC known comma. Yes. So this one is called in assembly. It's let's see the jump to table. SRC activation. It's just, oh no, it's in the care ops. Yes, SRC activations .rs, SRC frame activation .rs, and I'm looking at this table. Okay, so that's if both then else. Swap BC with underscores. Floor, it's not implemented anyway, but floor. To power of integer, and we have an op. Okay, that was absolutely not painful. And now, so we've done without CRD, we've done CRD by hand. So now, hopefully, I can cargo check, and it still wants CRD, except now I can. Yes, it's okay. It will be fine. Don't worry. We'll fix it. Where is it? Sigmoid. So here I'm going to do this is a slice of op, so I'm going to iter map op to pair and collect to a vector private. So it's in SRC ops. SRC frame activation ops. It will compile façon CRD here. Certainly, and I just want this to be pub. What's wrong? Yes, I said that before. I need T to be copy, but that shouldn't be a big problem because LA datum has to be copied already in its full definition, which we probably don't want to rewrite like this. Ab is apps, or else it's going to be taken as a variable name, and it should be better now. Whoa, compiles. Okay, so okay, let's try to craft the assembly very quickly, because ARM64 SIMD, ARM64 act F32 32 blah blah blah. So I'm going to define so that one I don't need, but I need this one, I need that. I'm going to get all of this. Yes, and that's just going to be a new function which I'm going to call act sigmoid, because I already have a sigmoid function somewhere else, but I'm pretty sure it doesn't have the act label in it. So I'm keeping that, I'm keeping this, that's fine. I'm getting rid of that, including the jump table. Okay, and I will need the end of the function, so that's it. Unsupported, I will probably don't need it. I won't need it. Yes. Okay. And so the inner loop goes here, and this is where I should try to expand all the things that we had before. So and oh yes, we have something else to fix. So this, the first function was taking the operator in XO. So we don't have the ops anymore, we just have the values and the length. So we need to offset XO1 and 2 by 1. Let's do that very quickly. So that's here, that's our sigmoid, T is gone. And so I need to compare, so x2 becomes x1. That one goes away. X1 become x0. X1 becomes XO. X1 becomes XO. One more. And X2 becomes X1. This is a return value, so if everything goes right, I put a 0 in the main return value of the function. I don't want to change this. And so this is the magic has to happen. And so will I be able to iterate over the sigmoid thing? So for, I don't even know if I can write it like this. So it should be op and t in sigmoid. Is that how the symbol will be defined? I don't know. Sigmoid and for op. So the generated assembly should be somewhere. It should be somewhere. Yep. Find. So I need to. Yeah, I will find it if I'm doing something like that. Act sigmoid in target. It doesn't show up. So it means that my code hasn't been generated. So what if I touch build just to course it into doing it again? Okay. Show up, please. No. Why? Because it compiled for Intel. Okay, I need to compile for ARM if I want this code to activate. Okay. So that's not how it's done. So what if I'm looking at pair? Does Liquid show error in compile template? I think you have the answer now. Pair. Okay, so now my problem is I have several times. Yes, I can do it like that because these dot labels are only unique in the context of one file. And here I have return, okay, done, all of these twice because I've put two files into the same file. So what I'm going to do, I'm going to copy this file. I'm going to split essentially ARM64 SIMD, ARM64 SIMD act, and I'm adding sigmoid here. So now editing the first one. Aha! There is all the templating that I need to somehow access from the two files. Oh! Okay. So I'm going to. I want to. I mean, I would like to get it to work because I'd like to. I'd like to close this now. I mean to wrap it up. So what I think I'm going to do instead is I'm going to break all the activation and just leave the sigmoid working. I mean, there are ways to have include in the temple file, so, and that's what we want to do, but I don't want to do it tonight. So I'm going to just replace the current interpreter by the sigmoid function and try to see if I can get it to work. Yes, and even that will be dirty because I still need to. Yes, okay, I'm still doing that, I guess. Act F32. It's going to be dirty because I cannot just cut all of this file. I need to keep my little captures. So yes, that's what I need to do. Just keep the capture sections. It's okay, it's not so bad. The thing is, it's not even. I mean, this thing is terrible, right? But it's not even the worst thing I did today. In terms of repeating stuff and hurting my fingers, and I've done way worse because when I need to change the main up trait in tract, then it's typically a full afternoon of just trying to not hurt my arms and fingers and everything because it's just editing. Maybe that's something that yes. Yes. Who are you? Fleetwood? Oh yes, you're my colleague. Yes, okay. Yes, that one was okay. I mean, that actually one was okay because in many cases it was just removing a macro call that was done on each and every macro. So actually, that one was a big Perl, big one-liner in Perl plus some fixes, But that's I've done much more difficult ones actually, where you actually need to open all the files and fix them one by one. Okay, so that was the last one. Let's try to focus again. So I'm discarding this because this is remaining from the previous function, and that's the sigmoid. So let's try and see. I mean, at this point shouldn't do anything because we have just commented stuff. What? Return is already defined? I wonder if I think it's having fun with me. Okay, it's act sigmoid f32. So that's the other file, yeah, because I did a copy before doing that. And the other file is still... Yes, no, that's right. I mean, and I was thinking, I mean, if you spend hours trying to write the pattern in some kind of difficult language and stuff, and I was wondering maybe that's one case where you want a LLM to write it with you. Maybe, I don't know. Yeah. Act. So I'm discarding this. Which one did I edit? I edit that one, yes, and so I want to discard the one with sigmoid in the name. Activations, RM, ARM64. It would be nice if we could make it into something that works, because I'm starting to be tired. Act, and that's sigmoid I want to discard, yes. So now, Rust CGPT. Now what we should see is in the assembly, we should see something in the comments. I don't exactly know what. I'm just hoping it will be usable. And what's wrong? So it's looking at, yes, so it's looking at the old function, the one I discarded, and it's not finding it, which makes sense because it's no longer there. So in src ARM64, that's the one. ARM64 SIMD. I have the act thing somewhere, and I just want to comment it. Okay, so it compiles, it tests, which makes sense because we're not testing the new function, the new sigmoid. And what I wanted to see if will the assembly contain something that I can make sense of. Okay, so I found some files, and the files I want to look at should just be called act, so I guess that could be the one. That one is empty, so hopefully not. Okay. What the fuck? Why is it empty? That I don't understand. Oh, because it's a previous crash. No, they're not. They're not bottleneck. I mean, it's interesting in one specific case, which is the support, the platform. I'm trying to not say too much. The platform that support F16 are interesting to me, and on these ones, if I'm just using Rust, as Rust doesn't have support for half float stuff, then all of the operations that are in the activation functions will be dramatically slow. Because basically I will convert from F32, I mean from F16 to F32, then do the math, and then back to F16. And as some of these activation functions are already split in the current implementation, the one in production, as they are split into sub operations, then each of them will do such a conversion, and so that one are going to be super slow. Beyond that, on F32, the Rust code is relatively good. There is one exception to that, which is the sigmoid and hyperbolic tangent, where it made sense to do the uncrafted optimization. I mean, it improved things. It was measurable, but I guess that for hard switch and stuff on F32. But also it's fun, right? I guess. I mean, there are like 4 people watching tonight. So 4 people who find it fun or interesting or just are dead beyond the screen. I'm trying to find the right function, the right file to open. Fine with me, yes. And let's. Yeah. And now 5, so we are 6 crazy people to find this interesting. So let's see. So back where... So many? Come on. We have a lot of them, and I'm not sure why. Oh, yes, because we have many lines, because it's in the for loop. Okay, makes sense, actually. Except, no, that doesn't make any sense. I mean, why is it empty? Oh, no, it's not empty. Damn. Okay, no, it's not empty. It's just... So this is obviously a mistake. So I missed... So yeah, I mean, the liquid template, we have spaces between the capture, and so that's why the file look empty. It wasn't empty at all. Let's try to find why we have this one. That's add by a const, add const. Where are you? Add is fine. Sub mul max add const. I guess I forgot to remove. Yes. Okay. All right. So moving on. Hello. So we have, it's not so bad. I don't know how I can split them now, but maybe like this? What do you think? I need an expert in liquid. Okay. Hey. So I think we may have a problem with the. Yes. I mean, I don't think I can put this crap in assembly and expect it to work. I will need to convert them to integers. I don't know if it's gonna work. Plus, oh yes, we're not done, and I'm gonna stop there because in the const operator, I mean, there is this bit that I need to change to give it the constant directly instead of reading it into W3. So we are very far from getting this to work actually, and as I already said repeatedly, I'm tired. So guys, I think that's it for tonight. We've done some absolutely terrible thing in the last hour, so I think it's better we stop there because we do even worse. But the commit before that was pretty good. And yes, I mean, I'm going to have to think about maybe a better way to do some of what we did today. You are 6 person viewing this right now, I think, except from the one time I was raided by like 20 people, one of my very first stream. So that's a record. But yeah, guys, I'm calling it a day. So hopefully see some of you next week. And if you're bored, there are like 10 sessions of 2 hours of this on YouTube. So enjoy. See you guys.